Hi, we're on Unit 7, Lesson 16. Go ahead and pause and hit unpause when you're there and you're ready to go. Unit 7, Lesson 16. Is a smartphone smart enough to go to the moon? Let's compare digital media and computer hardware using scientific notation. So, to answer that question, is a smartphone smart enough to go to the moon? Hopefully you already know the answer. We're gonna compare numbers that will make it obvious, but I know that I've heard numerous times a smartphone is way smarter than any computer that was ever used back when at least back when Apollo 11, like the one that is showing right there. There's much more powerful computers and rockets these days, much more powerful. But the technology that the rockets had back then was nothing compared to what a smartphone is today. And we'll show how and why right now. First off, it says 16.1, a warm-up problem. This is by no means a warm-up. There's only 2 activities and there's no homework. So make sure you follow along and show your work in your workbook so I can give you credit for this when I get back. So let's get started. Old hardware, new hardware. In 1966, the Apollo guidance computer was developed to make the calculations that would put humans on the moon. Your teacher will give you advertisements for different devices from 1966 to 2016. Choose one device and compare the device with the Apollo guidance computer. If you get stuck, consider using scientific notation to help you do your calculations. So, as you just heard, you can use scientific notation. It doesn't hurt. It's much easier, more efficient, but you don't have to. Either way, you're kind of using it and you're kind of not at the same time, as you'll see. But I'm not going to give you different advertising. I'm going to give you what's most relevant. I guess some people are more aware of the processing power and the memory power and the the storage power of computers, but most people know about cell phones, so that's what we're going to talk about. So number 1 says, which can store more information? How many times more? So if you didn't know, and I expect you not to know, but the computers used to get the rocket to the moon back in 1969, they had a storage. Their storage was about 75 kilobytes. Their processing power, that's like the computer chip they used to process calculations, was about 2. I wrote KB, hopefully everyone knows that means kilobytes. 2 megahertz. And their memory was roughly 4 kilobytes. You guys probably know more about computers than I do, but storage is kind of like how many pictures you can put on your computer before it says storage full. It's like space, it's the amount of things, digital things you can hold. Processing power is kind of like how fast it can think. It's always running X and O's or 1s and 2s. Or 0s and 1s. How fast it can calculate these 0s and 1s. And then memory, it's like a working memory. It's different than storage. It's like how much memory it can store while it's thinking. So that's why they say if you have so many tabs open on your computer, like I always do, don't ever look at my computer. You're going to say, Mr. Rogers, Oh my gosh, I have so many tabs open. As you can see, all these tabs up here on the screen, I still have too many, but I have 7th grade stuff and 8th grade stuff. Oops, and there's some 7th grade stuff. So the more tabs you have and the more working memory that you're using on your computer, it can slow down your computer. So long story short, that's what the Apollo had. I already spelled that wrong. That's what the Apollo had. Now, many of you may or may not know, your cell phone, the storage it has, typical cell phone, most of them these days, anywhere between 32 and 64. Well, some have one, we'll say 64. Some have 256, some have 512. And I shouldn't say kilobytes, these are gigabytes. Some older ones have 16 or 8. But on average, somewhere around there, it doesn't matter. We'll just go with 64. That's gigabytes. The processing speeds are typically, there are like 4 chips in a phone now. They have these quad processors. There's 4, and each one goes about 2.2 gigahertz. And then processing speed, or the memory, the memory is somewhere around 3. Some have 4, some have 8, some have 6. Most right now I see kind of have 3 or 4, but we'll just say 3. And if you want, you could literally, I don't know the button, but if you go into your settings, you could actually look and compare your phone or the phone settings that I've given you right now and look at your Chromebook as we speak. I don't have a Chromebook here, but your Chromebook has very similar specs to what I just gave you, which is crazy because a tiny cell phone has about the same processing speed as your Chromebook. They're all pretty decent. I'm not sure. I don't know what your Chromebooks are, but if you go into settings and somewhere you can find it underneath computer information. But we haven't answered the question. First off, which one can store more information? 75 kilobytes or 64 gigabytes? Well, first off, you need to know that 75 kilobytes, a kilobyte is 1,000 bytes. So we can say it's 75 times 10 to the third. That's 1,000. Now, a gigabyte, on the other hand, and by the way, all of this is right here I'm looking at. A gigabyte, on the other hand, mega stands for a million. A gigabyte stands for a billion. That's 9 zeros. So a gigabyte, this is 64 times 10 to the 9th. So 75 is a bigger number, but this has 9 zeros. That has 3 zeros after that. So question, which one can store more information? The cell phone. How many times more? So on Wednesday, I believe it was, I purposely rewrote the activities so we could, what does that even mean? So that we could understand how many times more. What does how many times more? And I gave us a very easy activity that says, hey, I have 2 marbles. Someone else has 10. How many times more? How many times more means it's a division problem. And we're going to take, in this case, the bigger one. We're going to take 64 times 10 to the 9th and divide it by the smaller one, 75 times 10 to the third. That'll tell us how many times more space that has. And in this case, I'll allow us to not be exact. Will be rough. We're going to estimate. In other words, 64 divided by 75, that's roughly, I don't feel like getting out of a calculator, that's roughly 0.9, maybe 0.8 would be better, but we don't have to be exactly. And then 10 to the 9th times 10 to the 3rd, what do we do there? If you said subtract the exponents, you're so right. Now I could leave it like that, but I am going to move this decimal over one. I'm going to make the 0.9 into a 9 because it wants scientific notation. It did say consider using scientists. I guess we could leave it like that. Down here it says give your answers using scientific notation. So we could leave it like that, but it doesn't take but a second to change this. I'm going to make that 0.9 bigger, so I'm going to make this smaller. And that just makes me see 9 with 5 zeros. 9 with 6 zeros is 9 million. So one place value left. It is 900,000 times. It has 900,000 times more memory. Our cell phones have 900,000 times. Let's just call it a million. Our cell phones have 1,000,000 times more memory than the computers that they used to send the Apollo 11 to the moon, which is just ridiculous. Now, which one has a faster processor? Well, Apollo has 2 megahertz. Down here it says a megahertz. Mega stands for a million. So that's 2 times 10 to the 6 hertz. Megahertz, a hertz, again, you might know what, but hertz are like, it's like a frequency. It's the amount of, is it per second? It can do like 2 million something per second. I don't know. Hertz, some kind of frequency of some sort. So that's that. Now, 4 times 2.2, we're going to just call it 8. 4 times 2 is 8, and that's a gigahertz. A gigahertz. Remember, giga stands for a billion. So this is going to be 8 times 10 to the 9th. I'm guessing that's how it's processed. If you have 4 of them going 2, then maybe it's 8. Don't quote me on that. This could be completely exponential in a different realm. But if 4 are going 2, then maybe that means that altogether that's 8. If it's 2 gigahertz, then 4 of them would be 8 gigahertz. And a gigahertz is 10 to the 9th. So the 1 megahertz, right? Did I do that right? Kilo stands for, mega stands for a million. Giga stands for a billion. So how many times faster? Remember, that means it's a division problem. So I'm going to take that and divide it by 2 times 10 to the 6. And what's that going to equal? Well, 8 divided by 2 is 4. We actually do the division on the numbers. And 10 times 9 divided by 10 times 6, that's 9 zeros divided by 6 zeros. 6 are going to cancel 9 of those, which means we subtract. So it's about 4 times 10 to the 3rd. That is in scientific notation. It's 4,000 times faster. Our computers these days go 4,000 times faster. And I'm not even 100% sure because I don't want to say they're going faster than that. I think our computers even go faster than that. But that's still significant. Our computers go 4,000 times faster than they did back in 1969. And then which one has more memory? How many times more memory? 4 kilobytes. Well, I'm going to write the bigger one. The memory 3. I should have said gigabytes. And make your life easier, let's just call it 4 gigabytes. Lots of cell phones have that. Because that way I have 4 and 4. So 4 gigabytes, which remember is a billion bytes, divided by the memory 4 kilobytes. 4 kilobytes is, kilo stands for 1,000, and 1,000 is 3 zeros. So guess what? 4 divided by 4 is 1. And 10 to the 9th, you got it, we subtract. So how many times more memory? About 1,000,000 times more working memory. I'd like to double check that faster processor one. We could Google it, maybe. But let's move on. I should have checked that. I don't even know what time this video started. And sometimes I go on too long. Okay, number 1. For each question, a bit more in bytes. Think about what information you need. Your teacher may provide you. I may. Give your answers using scientific notation. Well, good news is we just did that in the last one. I found an 80s computer magazine with an advertisement for a machine with hundreds of kilobytes of storage. I was curious and asked, how many kilobytes would my dad's new 2016 computer hold? Well, first off, that's probably not new if it's 2016. But most computers these days, on average, most don't really have a terabyte. It's becoming more and more common. And if you look right there, a terabyte is a trillion. Hundreds, thousands, millions, billions, a trillion, which is a lot. But most of them have about 500 gigabytes. Usually it's like 512 or 256. They go in, don't quote me, I don't know why. Actually, it does say something like that. Something, binary. They go by, not necessarily that, even though it says kilobyte, it goes by powers of 2. Maybe that's why it's 256 and 64. 2 to the 5th is, or 2 to the 6th is 64, to the 7th, and 1. Yeah, maybe that's why I never realized that, but it's using binary bytes. But for the sake of this, we won't say 512, we'll just say 500. We'll say it's 500 gigabytes. Gigabytes is a billion. 500 times 10 to the 9th. And how many kilobytes? A kilobyte is just 10 to the 3rd. So how many kilobytes are there? Back then, they literally computers were like, hey, this has hundreds of kilobytes. Well, let's see how many kilobytes are in a newer computer. 500 times 10 to the 9th. Well, notice, if I really wanted to, I could put a 1 times 10 to, so that we could see 500 divided by 1 is still just going to be 500. And 10 to the 9th divided by 10 to the 3rd, subtract the exponents, and I get 10 to the 6th. So it's 500 million kilobytes. So computers back then said, wow, there's hundreds of kilobytes of storage in this computer. Well, using that same, and we don't talk about kilobytes anymore because they're too small, but if we did, we would say, wow, our computer has 500 million kilobytes instead of hundreds. Computers these days have 500 million kilobytes. So this is not correct yet because it is not in scientific notation. So I got to go back 2 place values so that I get it in between 1 and 10. So if I made the number smaller, I got to make the exponent. If I made it 2 place values smaller, the exponent's got to get 2 times bigger. and both still represent 500 million. Number 2, the old magazine showed another ad for a 750 kilobyte floppy disk, a device used in the past to store data. How many gigabytes is this? This is sad because this is when I remember when I was in 4th or 5th grade. I remember using floppy disks. You guys maybe had never heard of this, but you gotta see these weird things. Let's go to images. Oh, those are hard disks. This is what we use though. This one on the left, wow, I don't even remember that big one. I guess it's the red one and the blue one is what I remember. The floppy disks, they're literally floppy, like not like quite like a piece of paper, but you can sit there and flop it like a picture. And then that blue one, that was a hard disk. It had slightly more space, but I remember playing games on these floppy disks, and you had to, once you got to a certain point in the game, you had to take the disc out and put the next one in. And believe me, these were like block games, like Pong and stuff like that. But long story short, I do remember them, and was not quite clear on how small they are compared to what we have today. So the old magazine showed another ad for a 750 kilobyte floppy disk device. How many gigabytes is this? Well, first off, it's not a gigabyte. It's not even remotely close to a gigabyte. It's a fraction of a gigabyte, which tells me that I need to take this and divide it by a gigabyte. And by the way, kilo means times 10 to the third. 750 kilobyte, which means 750,000 bytes. Sounds like a lot, but a byte is like one character. We'll get into that, I think, in a one character. If I type a letter, that's 1 byte worth. And how many gigabytes is this? Well, gigabyte is just 1 times 10 to the 9th. That's still a billion. So what does that equal? 750 times 3 minus 9. It's a -6. So that's not in scientific notation. But I am going to go ahead and write this. 750 times 10 to the -6. So I go back 1, 2, 3, 4, 5, 6. Just so I could see the number in real life. That's how many gigabytes a floppy disk was. It's a tens, hundreds, thousands, 10,000s, hundreds. It's 7,500 thousandths of a gigabyte. Tiny. So if I make this scientific notation, between 1 and 10 means that's got to become a 7.5. So I just made it 2 times smaller, which means I got to make this 2 times bigger. What would -6 making it bigger means? The negatives are going to be something smaller. It's going to be a -4. My and her friends, well, we got to motor on. We got to pick up the pace. Maya and her friends were actively involved on a social media service that limits each message to 140 characters. Sounds like Twitter. She wonders about the size of a message compares to other media. Estimate how many messages it would take Maya to fill up a floppy disk with 140 characters. So a floppy disk is 750 kilobytes. So if I divide that by, I could just say 140, and that's fine. And it says estimate, so I'm going to pretend that's like 150, because 150 goes into 75 very nicely. Be 15, 30, 45, 60, 75. That would be 5 times 10 to the third. Notice I divided that. If I really wanted to, I would say, well, what do I do with that 10 to the third? Well, that's still there. I could say this is 10 to the 0 power, because remember, anything to the 0 power is 1. And I subtract 3 minus 0, I still get 3. So it's about, how many messages would it take? She could write 5,000 messages and it would fill up a floppy disk. And these days on our phones, we could do 5 billion messages, quite literally. So, if that's 5,000, it says estimate how many messages it would take for Mai to fill a floppy disk with messages that use only emojis. An emoji, if you didn't know, takes up about, well, each character is a byte, I think, for number 3. An emoji is about 4 bytes. Each character here was 1 byte. I forget if I mentioned that. Characters about it, I think I did at some point. So if there's 4 bytes in an emoji, and if it was 5,000 floppy disks, for 1 byte, 140 characters that are 1 byte, well, if this is going to be 4 times as big, I'm pretty much taking 5,000 come on now, and dividing it by 4. Everything's 4 times bigger. An emoji is 4 bytes versus a character just being 1. So when it says estimate, 5 divided by 4, let's call it 1. It says estimate. So it's going to take, if I use emojis, about 1,000, maybe slightly more, 1.25 if I really wanted to. That'd be fine. That'd be in scientific notation. Either way. Let's go to number 5. Mai likes to go to the movies with her friends and knows that a high-definition film takes up a lot of storage space on a computer. Estimate how many floppy disks it would take to store a high-definition movie. Explain or show your reasoning. Let's read that again. She likes to go to movies, knows that a high-definition film takes up a lot of storage. That's true. High-definition, they are big. If you didn't know, they're roughly, but a good high-definition movie typically is about 8 gigabytes of space. They take up a lot of space. Most times, standard definition is sufficient for watching on a phone or a computer. Not to mention a lot of screens don't necessarily even go high def, so not even worth the time or the space. But 8 gigabytes is about a high-definition movie. So how many floppy disks would it take to store a high-definition movie? Well, we're going to take 8 gigabytes, which is like 10 to the 9th bytes, remember, 8 billion bytes. And remember, a floppy disk was 750 kilobytes. So we have 750 kilos. Kilo, just like a kilogram is 1,000 grams, a kilobyte is 1,000 bytes. So that's going to equal something. And it says estimate. So before I get out my calculator and try to say, hey, what's 8 divided by 750? Whatever my answer would be, it's going to be times 10 to the 6th, and that's fine. It's going to be a decimal, obviously, a very small decimal. 8 divided by 750 is going to be 0.01, or I don't know. But either way, I can make my life a little easier. I'm going to change the spot. I'm going to leave this as 8 times 10 to the 9th. And I'm going to move this back and make it scientific notation. And I'm going to say that's 7.5. I moved it back 2. I made it smaller 2, which means I made to make this bigger 2. So I'm going to make that a 5. Let me make it a little clearer. Now, when I look at it that way, when it says estimate, now I see, hey, 8 divided by 7.5. That's like 8 divided by 8. I'm going to do a little wiggly mark. That means I'm estimating. So 8 divided by 8 is just 1. I'm estimating. And 10 to the 9th divided by 10 to the 5th is 10 to the 4th. So guess what? That's about a 1 with 4 zeros. That's 10,000. It would take 10,000 floppy disks to store a high definition movie, meaning I would have to put in 10,000 floppy disks to watch a movie these days. So, how many seconds of a high definition movie would one floppy disk hold? Well, if it's 10,000 floppy disks, and let's just say 1 second per floppy disk, that'd be 10,000 seconds. Well, first off, I guess we got to figure out how many seconds a high definition movie. Let's say a movie is 2 hours. Times 60 minutes. That's 120 minutes per movie times 60 seconds. That's 72 it is. So that's 7,200 seconds, right? And it says how many seconds would one floppy disk be able to hold? So if a movie is 7,000, did I write times? I should write 72 with 2 zeros, I think. There's 60 seconds in a minute. So I believe there's 7,200 seconds in a movie. What do we need to do with this number? We've either got to do 10,000, we got to do this number, because that's how many floppy disks there are. We either got to do that divided by 7,200 or 7,200 divided by that. For one, we want to know what one floppy. So per one means we're going to divide floppy disk. So we got to do this divided by 1 times 10 to the 4th. I could do 7,200 divided by, if I really wanted to. It's not like I have to use 1, 2, 3, 4. I could do that. Zeros cancel, zeros cancel. And 72 divided by 100 is 72 hundredths, which is, as a decimal, 0.72. So that's our answer, 0.72 seconds. Not even a full second. A floppy disk wouldn't even hold a second. It would be 0.72. It says answer in terms of scientific notation, so I'm going to move this to the right one. And that's 0.72 times 10 to the 0, anything. So if I move it right one, I got to make the 0 smaller. I made the number bigger, so that would be scientific notation. 10 times 10 to the negative 1. Kind of going fast there. If you need to pause, hit rewind, or hear me say that again, please do. Because those are some basic but not common steps that we have to take. If I say, hey, write 0.72 in scientific notation, well, I got to make a 7.2 instead of 0.72. So making a 0.72 bigger means I got to make the exponent smaller, and there's an invisible exponent that I had to come up with, because anything times 1 is itself. So I wrote that 10 to the 0, and to make the exponent smaller, I make it a negative 1. All right, let's do one more and let's call it a day. If you fall asleep watching a movie streaming service and streams all night, how many floppy disks would that be? Well, if it's 10,000, if it is 10,000 or 1 times 10 to the 4th floppy disk for a 2-hour movie, let's say you sleep for 8 hours. Hopefully you're getting at least that. Well, if that's for a 2-hour movie, times that by 4, that would be 8 hours worth of movies. A 2-hour movie times 4 would be 8 hours. So it would be 4 times 10 to the fourth. That is in scientific notation. And that would be about 40,000 floppy disks. Be a lot of floppy disks. Long story short, wow, our computers are more powerful today than they were back when I was growing up. And it's only getting better. Like, if you want, Google some of these quantum computers that they're getting up and running. They are unfathomable, and they're only going to be, you're going to be saying exactly what I was saying when you're this old. When you're my age, you're going to be going, man, my cell phone used to only be able to play Roblox, and now that, whatever like you do with your cell phones. My cell phone could only watch TikTok videos. Now they read people's minds. Who knows what they're going to do. But anyway, let's call it a day. Have a fantastic weekend. If you take a look at Lesson 16 homework, go ahead and do that for this weekend, and we'll call it even. Do all of Lesson 16 practice problems. There it is. Lesson 16 practice problems. Do each and every last one of them. And I was just joking. Notice there are none. We're going to call it good for now. Have a good weekend. On Monday, I'm thinking we're going to go over some of this stuff on how to add using scientific notation, how to subtract, how to multiply and divide. We'll do a little bit of review. And then it'll be time for the very last unit on Pythagorean theorem and irrational numbers and all that wonderful, wonderful stuff. Have a good weekend.